So continuing with the quadratic formula, we're going to go ahead and plug in examples 3 and 4, and we're actually going to simplify these this time. So if we look at number 3, we've got 5x squared minus 5x equals 7. Well, the quadratic formula doesn't work unless the right-hand side is equal to 0. So the first thing that we have to do is move that 7 to the left-hand side by subtraction. So the first thing I'm going to do is write 5x squared minus 5x minus 7 equals 0. And that step is super important because if I don't have that equation set equal to 0, the quadratic formula is not going to work. Excuse me. So I have rewritten the quadratic formula over here so I can keep referencing it as we're plugging these values in. And so now we need to look for what's A, B, and C. So A in this problem is 5, B in this problem is negative 5, and C is negative 7. So I'm just pulling those values straight from the equation. A is 5, B is negative 5, and C is negative 7. Well, then it becomes a giant plug and chug problem. So let's plug those in. I apologize if my hand's in the way, but I will move it in just a second. So it's negative B, so it's negative negative 5. So that's going to be 5 plus or minus the square root of. Well, B squared, B is negative 5. Negative 5 squared is 25 minus 4 times A, which is 5, times C, which is negative 7. And it's all over, so I told you I would say all over a bunch of times, because it's a giant fraction bar, all over 2A, and 2 times 5 is 10. So I did a little bit of simplifying, because I did negative negative 5 to get a positive, and I went ahead and squared B, because it's B squared under the square root. Negative 5 times negative 5 is 25. Well, now I still have this business under the square root to clean up. So my 5 is fine out front, plus or minus the square root of, well, I have 25 minus 4 times 5 times negative 7. Well, 4 times 5 is 20, 20 times 7 is 140. So it's really 25 plus 140 all over 10. And that gives us 5 plus or minus the square root of 165 over 10. And if you get to this point, I'm going to be super happy with you because it gets us to almost probably the most simple form we can get. The issue is we have to check this thing under the square root. I know you've slept a lot since then, but we did a bunch of problems simplifying square roots. And a lot of it has to do with, or the reason we need that skill, is so that we can simplify our roots here. So if I look at 165, and I want to try to see if it has any perfect square factors, the first thing I would divide it by is 5. 165 divided by 5 is 33. So it doesn't have any perfect, it's not going to have any perfect square factors because the prime factorization would be 3 times 5 times 11. None of those are perfect squares and they don't contain any perfect square factors themselves. So actually for this problem, that is the simplest we can get. And I know that that's ugly and I know you don't like it and that's okay. We're going to deal with that. But this is going to be our answer. And you're saying, Miss Ball, we're supposed to have 2 answers. And we do. We have 5 plus the square root of 165 all over 10. We also have 5 minus the square root of 165 all over 10. So it looks like one answer, but the fact that we have that plus or minus in there is telling us that there's really 2. I promise. The more you do it, the better we'll feel about it. So let's look at number 4. Again, if you look at number 4, the right-hand side's not equal to 0. So the first thing I have to do is move the negative 3x to the other side by addition. So 4x squared plus 3x plus 3 equals 0. And again, this step is key because the quadratic formula does not work unless you have it set equal to 0. So here our A is 4, our B is 3, and our C is also 3. So again, I'm using the quadratic formula, which you've seen me write out 3 or 4 times now, so I'm not going to write it again, but I'm going to be plugging these values in. So if I look at that, I have negative B, so negative 3, plus or minus the square root of B squared, 3 squared is 9, minus 4. 4 is a constant in this equation. I'm not making it up, it just is part of the equation. A, which is 4, C, which is 3. So it's 4AC all over 2A. Well, 2 times 4 is 8. So that's the first step in plugging the values in the quadratic formula. And like I said, when we do the quiz on this, if I see that step and then you have mistakes, we're going to be okay, because this shows me that you know how to plug the values in. Somewhere there's a calculator issue or we struggle a little bit simplifying our radicals, and we'll see how that works out. Okay, so let's clean this up. So I have negative 3 plus or minus the square root of 9 minus, well, what's happening here? I have 4 times 4 times 3. Well, 4 times 4 times 3 is 48 all over 8. So it looks better. So I have negative 3 plus or minus the square root of, well, 9 minus 48 is negative 39 all over 8. So we have negative 3 plus or minus the square root of negative 39 over 8. Well, I have an issue with that. And the issue is that I can't take the square root of a negative number, because the square root's asking what number times itself gives me that radicand, the number underneath. And there is no number times itself that will result in a negative. That will never happen. So at this point, if you're using the quadratic formula, and this will happen sometimes, if you get a negative radicand, what you're going to tell me is that there are no real solutions. And that happens. We'll talk about that in the next video, what that means graphically for our quadratic, but algebraically, if you get a radicand, meaning the number under the radical once you simplify, that is negative, you're going to tell me no real solutions. I promise the more you do these, the better you're going to feel about them.